Hi, I'm Narine, this is Hadi and Ray, and we'll be presenting our Project 2, which is a robotic platform programming.
For our first task in the project, we developed a synchronized dance for 2 different bobots. We divided the main task into 5 main objectives. The first one being to develop a dance and pick a song according to everything we've learned in class. We chose Tootsie by 69 Boys, which is a good application of what we've developed in class, including the programmings and everything else. Our second objective is to write the program, which has to go according to the song and follow along with the words in the song. We synchronize the song accordingly, which we do by changing the pauses and having everything run smoothly along with the song. And then we apply it to the second bobot, which involves some inversing so that it looks like they're dancing together. Right now I'm going to show you some of our particular moves that we created for this project. The first one is called the Tootsie Roll, which basically just involves the robot doing clockwise and counterclockwise rotation. The second one is called the Slide, which was achieved by having the bobot having one wheel spinning faster than the other and pausing in every loop, which causes a sliding motion in a circular manner, and having one wheel go slower than the other. The last dance is called the Dip, which was achieved by switching from forward to backward in a very succinct manner, which does a dipping motion. Now I'm going to show you the combination of both bobots together. And now Kelvin will describe our second task in the project.
So the second task in the project involved an environmental scan. Basically, the robot will spin in a 360-degree manner and find the furthest object. From then, it'll spin again in the opposite direction, locate that furthest object, and move towards it. One of the obstacles that we had to overcome in this project is it must avoid walls and other interferences. So the robot had to stay within the range specified. We utilized 3 phases in order for this project to be done. The 3 phases start from here. This is phase 1, 2, and 3. Phase 1 was the first rotation of the robot, where from 1 to 60, it did a 6-degree pulse and then found it got a sonar reading. From then, it kept going and it saved the sonar reading if the new sonar reading was higher than the old one. Once it got the sonar reading, it went to the second phase, which was to rotate the opposite direction and find that sonar reading again. Once the values matched, it went to the third phase, which moved forward to the object and stopped 2 inches before it. This is one of the examples of the robot finding the furthest distance. As you can see, it pauses whenever it finds the furthest distance, and then it rotates the other way, finds the distance again, and moves towards it. Here it does a scan, it found a distance greater than the previous one, another distance greater than the previous one, and it rotates back the other way to find the furthest distance, which was here, and it'll stop 2 inches before it. And that was task 2. I'll pass it over to Hadi, who will demonstrate task 3.
The task 3 has been accomplished with the purpose of keeping the distance of Bobot in a certain defined position from the object, from a moving object. And for this purpose, the sonars have been used to measure the distance from the object, and with constant multiplication, it is converted to the distance, and then based on the measurement, and a tolerance has been defined to show that how the Bobot should keep itself in a stability, how the position is to the object. The Bobot continuously measures the distance from the object, and if the distance was in the range, our acceptable range, it wouldn't move. But if it was less than this range, it will go farther, and if it was more than this range, it will go closer. So the challenge of defining the error was the main challenge of this programming, because the negative values are not defined in p-basic. So I have to shift all the values to a certain value to be able to accommodate with this problem. And also the stability was another issue. So here you see that the algorithm is very simple. The Bobot starts with defining the distance, which can be variable within the range of Bobot's sonar's acceptable and without more errors. Then calculate the error set and also the tolerance, measure the distance and calculate the error. If the error was less than the tolerance, then don't move. This is the part which is defined for keeping the Bobot stable. Otherwise, it continuously shakes and it is not stable. Then, if the error was more than the error set, go forward, and if the error was less than the error set, go backward until it reaches to a zone that is acceptable. Now here you can see a video of what's going on. So here, Bobot adjusts its distance continuously with the moving object. So, thank you.